This is Gleason's New Standard Map of the World, and a lot of people claim that it does exactly what it says here at the top, show the world as it is, scientifically and practically correct. So let's take a look at this map and see what it shows us. Of course, this is a flat Earth map. We have north in the center, and south is around the entire planet. The Antarctica is the ice wall that encompasses the entire planet, and all of the continents are contained within that ice wall. So you can see all the continents here. We have Australia here. Here's North America. Here's South America. Somebody standing in South America facing north would be looking in this direction toward the center. And somebody standing in Australia looking north would be looking this direction toward the center. So opposite sides of the planet there, that seems to fit what we know to be true. Conversely, somebody standing in Australia looking south would be facing the ice wall in this direction, looking out here. And somebody in South America facing south would be facing the ice wall in this direction and looking out this way. So the question is, does this show the world as it is? Is it practically correct? And one of the ways to test that is to compare what people in these two continents are seeing when they look south. Because according to this map, they should see completely different night skies. They're facing in totally opposite directions, and so there should not be any common stars between the view that somebody looking south in Australia sees compared to the view that somebody looking south in South America sees. Now, even though these two continents are on opposite sides of the planet, there are some times where there is darkness in both continents, at least in parts of them, in the winter months. So here we are looking at July 15th. At 9 o'clock UTC, you can see we have a pretty good portion of South America in darkness and a piece of Australia here. So what we can do is compare Buenos Aires, Argentina, which is right here, and Sydney, New South Wales, Australia, which is right here. And here we're looking at a time when both are in darkness at the same time. The sun sets at about 5 p.m. in Sydney, which is 3 a.m. in Buenos Aires. So we have quite a lot of time until the sun comes up at 8 o'clock over here, where both of these areas are in darkness. And even if you discount an hour on both sides for twilight, and of course, before the sun comes up, we still have at least 2 hours of time when both of these areas are simultaneously in darkness, and someone could be looking south from both locations at the same time, and we could compare what they see. So again, according to this map here, if somebody is standing here in Australia and someone standing here in South America, and they are both looking south at the same time, there is no way they could be seeing any of the same stars. So let's find out what they are seeing. Here is the night sky in Buenos Aires at that time. Here we are on the 15th at 6 a.m. local time, which is 9 o'clock UTC. We're a couple of hours before sunrise. We are facing south here, so let's go ahead and make it a little larger so it's easier to see what we're looking at. And the first thing that jumps right out to me is right here, due south, just above the horizon is the Southern Cross. It's, in fact, just slightly below the horizon there, but we have the long section of the cross here pointing up, and that is very clearly visible here on the southern horizon. So this should definitely not be visible from Australia because it's right on the horizon. So if we're looking at the flat Earth map, it has got to be very low on the dome out in this area here somewhere because it is visible right against the flat Earth plane when you look south from Buenos Aires. So definitely right here somewhere. There's no way that somebody looking south in Australia should be able to see it. Now let's take a look at the night sky in Australia. Here we are in Sydney at 8 p.m. Again, that would be the same time as 6 a.m. In Buenos Aires because of the 14-hour time difference. When it's 6 a.m. in Buenos Aires, it is 8 p.m. that same day in Sydney, Australia. So let's go ahead and enlarge this and take a look at what we're seeing. Again, we're looking south. We definitely don't see the same thing on the horizon, but look here. Here is the Southern Cross. Definitely higher in the sky, but certainly still visible looking south. And in fact, look at all of these other constellations that are visible in both. Now, clearly we're rotated significantly from one view to the other, but here we have, obviously these two triangle-shaped constellations, and here are those two triangle-shaped constellations here. A lot of the same stars. A majority of these stars are visible in both locations at the same time. So that doesn't seem to make sense because on the flat Earth map here, this view that we're seeing from Australia, it's higher in the night sky, but it is certainly still south. The Southern Cross has got to be on the dome somewhere in here. Because we're seeing it definitely in a southerly direction. Now, one possible explanation that was suggested to me for how people standing in these two locations could see inverted versions of the same night sky would be if you have somebody facing south in Australia, somebody facing south in South America. They are, theoretically back to back. So if they look up, they are looking at the same dome ceiling 180 degrees out of phase from each other. So obviously they would see an upside down version compared to each other of the same dome ceiling. And that does make sense. If they're looking up at the dome ceiling, they would see the same dome ceiling from opposite perspectives. But there are a couple of problems with that being the explanation for what we're seeing. For one, we're not seeing the Southern Cross by looking up. In Buenos Aires, we are looking right against the horizon. So we're not looking up at all. It is right against the horizon in this southerly direction here. Another problem with that is that if somebody in South America and somebody in Australia are looking up and seeing the same dome ceiling, the same night sky just inverted, then everybody in between them would also be able to look up and see that same night sky in some sort of orientation. But that means that if you are seeing the Southern Cross in the dome ceiling here in South America and in Australia, then you've got to be able to see the Southern Cross from all of these northern areas, which is not the case. People in Canada can never see the Southern Cross in the sky. So that doesn't explain it. It seems to be completely contradictory what we're seeing in reality versus what this map is showing us. So the question is now, does the globe Earth do any better? And so let's take a look at a globe Earth model here on Google Earth. Here is Sydney, Australia. If we flip all the way over to the other side of the planet, here is Buenos Aires, Argentina. Of course, on the globe map, looking south means you're looking out in this direction. Here is the South Pole, which is where Antarctica is. This is the southern part of the planet. And so if we zoom out here where we can see the entire planet, and of course here is Sydney, Australia. Here is Buenos Aires right there. And if we go like this, we can see both Sydney, Australia and Buenos Aires at the same time. And if they're looking south, well, they're looking at us because we are hovering out over the South Pole right now. So if the Southern Cross is right here with us, then it would be visible from both Sydney, Australia and Buenos Aires, Argentina. And also you could see that somebody standing here in Australia is upside down compared to somebody standing here in Buenos Aires, which would explain how the views are inverted. So in this case, the globe model does represent what we see in reality, and the flat Earth model does not.